So page 1 in your big blue book of parent functions is a linear function. A linear function is something you have dealt with for years, probably since about 6th grade. So you know a lot about linear functions. If you're unsure of any of this terminology, you can look that up online. You can look it up. There's video explaining all of those too. There's all sorts of options, but here we go. The domain is the set of all possible x values, and as you know from the equation, there's no division by 0, there's no square roots, and on the graph goes everywhere. X can be any real number, and so you can either write it as any real number if you choose to do that, or we can write it in interval notation. X can go from -infinity up to infinity. No problem. The range, remarkably similar. Y can also go from -infinity to infinity. Y can be anything. Intercepts, as you can see, goes through 0, 0. That is both the x-intercept and the y-intercept. Y equals x does not have any asymptotes. So that's easy. Key points, as you see on the graph, we're looking at -1, -1, 0, 0, 1, 1, and actually just about anything. There is some symmetry on this graph, some lovely symmetry. It's a rotation by 180 degrees. It's a little hard to see because it's so simple, but this point here, 1, 1, if you rotate at 180 degrees, that gets you to -1, -1, that point there. And likewise, this one, if you rotate at 180 degrees, it comes up here. It's also called a reflection over the origin. So this point, if you bounce it through the origin and the same distance out the other side, that's where it comes in. So it's symmetric over the origin. That makes it, that's the same as 180 degree rotation. Yeah, I spelled it right the first time. And that makes it an odd function. If you're unsure on that, we'll get more on that going on. 1 to 1, this is a 1 to 1 function. Each x has one y, each y has one x. It's a 1 to 1 function. It is also continuous on its entire domain. So on the entire domain from -infinity to infinity, it is continuous. You can draw it without lifting up your pencil. It goes very smoothly. End behavior. As we're looking at the end behavior here, we're looking at what's happening as x goes out this end. As x goes to infinity, y also goes to infinity. Out this end, as x goes to -infinity, y also goes to -infinity. So there's your end behavior. As x goes to infinity, y goes to infinity. As x goes to -infinity, y goes to -infinity. There are no maximum and minimum points. It just keeps going. And increasing and decreasing, you can see as you go left to right, it is increasing everywhere. From -infinity to infinity. If you're looking at alternate forms here, we know a couple things. We know point slope form, which is y minus k equals m times x minus h, or you might know it as a1, as y1 or x1. You know slope-intercept form, which is y equals mx plus b, which is taking this graph and transforming it a little bit. You also know, perhaps you remember, standard form of an equation. Standard form of a linear equation is a times x plus b times y equals c. The advantage there is you can actually handle vertical lines, and you can't handle a vertical line with point slope or slope intercept because the slope is undefined. So that makes it tough. If it's undefined, you can't really use it. One last piece, applications. Anything that grows at a constant rate. How many miles per hour are you driving? How many socks per day are you knitting? All sorts of possibilities. Anything that grows at a constant rate has a linear graph, and it's all good. So that's your first page in your big blue book of parent functions, the first of many this year, the first of 5 that you're going to do in the first week, in fact. But there we go. Enjoy. Have a good day.